and we're bringing in the term rational exponents. So before we talked about rational expressions in Unit 1, and that was when we had a fraction which had polynomials in it. So rational exponent, okay, is related to the idea of fractions. So by the end of today's lesson, the idea is that you would understand how a fraction, how an exponent with a fraction like 3 over 2, what that would mean. Okay? We've got some new terms coming in today. So we've got the term, no, that's not what I want. Oh, this is what I want. So we've got the term index, radicand, and radical sign. Okay? As well as rational exponent. So if you're making your list of terms, those are 3 to 4 terms to add. And so we'll be working on evaluating or simplifying exponents. So evaluate means find the value, find a number. Okay? And so that would be a case where you can actually find a numeric value. Versus simplify would be a situation where we have variables like x and y, and we're just supposed to reduce the number of clutter of numbers there, right? All right. So students, you are familiar with the radical sign. This sign here, which you know of as the square root sign, is actually called the radical sign. And when we've used the radical sign, most times it has meant that we've been taking the square root of a number. Okay, and so when we're finding the square root, that meant finding two identical numbers that multiply to give the number underneath the radical sign. Okay, so if we had the square root of 9, we said, oh, 3 times 3 equals to 9, so the square root of 9 is 3. Okay, in this case, a number underneath the radical sign must be positive for there to be a real number solution. Okay, so this 9 has to be positive. All right, so the image to the left shows how we can define certain values when dealing with radicals. So we have the radical symbol, okay? Under the radical symbol, whatever is there is called the radicand, the radical symbol or radical sign. And then sometimes we will have a number or a letter in this position, and that is called the index. So the radicand is the number underneath the radical sign, the x in this case, and the index is the little number that sometimes is placed in the radical symbol. Now, when there is no index mentioned, that actually assumes that the value of the index is a 2. So what we mean is, if we just write square root of 9, that actually means like that's a 2, that the index is 2. And what that tells us is that there are two numbers that multiply to give you the radicand. Okay, if I look at another one, let's say the index is a 3. We've seen this one before. We call this the cubed root. And what that means is we're looking for 3 numbers, 3 identical numbers that when multiplied give you the value of the radicand. And so in this case, the cubed root of 27 is 3. How are radicals and rational or fractional exponents related? Okay, so let's understand how this and exponents that are fractions are related, because currently they look like two separate things. So let's examine the exponent law, where a to the power of n to the power of n equals a to the power of m times n, right? So if we have two exponents, we just multiply them. So in this case, 4 to the power of 1/2 all to the power of 2. And if we use the exponent law stated above, this one, we would get 4 to the power of 1/2 times 2, right? We would multiply the two exponents. Well, 1/2 times 2 is 4 to the power of 1, right? 2/2 is a 1, or straight up 4. Okay? So far, you're following? Okay. So now let's look at it a bit differently. What is 4 also equal to in terms of another base as an exponent? Okay, so a number that's raised. So how else can I achieve a 4? Well, I could write 2 to the power of 2, right? 2 squared equals 4. 2 times 2. Okay. So let's look at the first expression, this one. Okay, we said that 4 to the power of 1/2 to the power of 1/2, and we are asked to equate these two. Okay, so we are asked to equate these two expressions. Okay, now I'm actually going to change this exponent to make it a purple exponent so that we can visually see, well, an exponent of 2 and exponent of 2 are identical. So this implies that 4 to the power of 1/2 equals to 2. And what this tells us is 4 to the power of 1/2 is actually 4 square rooted. So when you have an exponent that is a fraction, we're actually taking a root. Okay, this implies that we are to use the radical symbol. Okay, let's practice this. So, oh, I was supposed to write the general terms. Oops, that was supposed to go up there. Let's put this here. And in general terms, we can say that x to the power of y over w equals, okay, put the x stays in x, the base becomes the radicand. Okay. The bottom of the denominator becomes the index, and the numerator remains as a power, right? So it's x to the power of y under the wth root. Okay, so let's see what this means. Okay. Let's look at these examples. Convert the expression into either rational exponents. Okay, so rational exponents means write an exponent that's a fraction, or into radicals. So this first one is a radical. So we have to convert it into a rational exponent. Rational exponent. Everyone paying attention? Who's got their phones out? Oh yeah, I see you. I knew it. Put that phone away. Good job, right? Because you care about math so much, right? I know. And this is fun. This is kind of fun. All right. Okay, I won't say names. That would just be embarrassing. But you know who you are. All right. So what we're suggesting, so we're going to practice going between these two forms. Okay. So we are starting in the radical form. And so the radicand, the 5, becomes the base. And now we have to write the exponent as a fraction. And so in this case, there is no power. The only thing we see is that this is the cubed root, so we write 1 over 3. Okay. Similarly, in the second case, we're given the expression as a radical symbol, or in radical form, excuse me, so we need to write it with a rational expression. So once again, the radicand, the 6, becomes the base, and then we have a fraction. So the square root part goes in the fraction. Now the power goes in the denominator. So the power goes in the denominator. The root goes into the numerator. And in this case, I can reduce this fraction. So it becomes 6 to the power of 2, 4 divided by 2. And in this case, we can evaluate it at 36. 6 squared is 36. Let's look at another example. Here I am given an expression in the rational exponent form, so I need to write the radical form. So once again, the base becomes the radicand. We draw the radical symbol. The denominator is a 2. That becomes the index. And since the numerator is a 1, I do not write 7 to the power of 1. Okay? So I leave it at that, square root of 7. And because I cannot evaluate this to get a perfect integer, I leave it. All right, lastly, I see I have 2 exponents, and they're both fractions. So let's simplify first. When we have a power of a power, this tells me that I multiply the 2 exponents, right? So we're going to multiply exponents first. So I've got 2 times 3 over 3 times 4. I can cross cancel if I'd like, but for simplicity, I will leave it as 6 over 12. Okay, 6 over 12 can be reduced to 1/2. And when I have 1/2, this is telling me that I'm taking the square root of 9, right, with an index of 2. We can write that in, we don't have to. The square root of 9 is valued at 3. Okay, we've got 2 more examples. Well, 4 more. Let's look at these first examples. So I'm asked to evaluate this expression. First of all, is this expression in rational expression form or radical form? Correct. This is rational expression. All right. And so a denominator of 2 means that the index is a 2 and the radicand is 25. So square root of 25 is equal to 5, right? 5 times 5. Looking at the second expression, now I have a negative exponent. Let's deal with that first. Okay, so the negative exponent needs to be cleared. So I have 1 over 216 all to the power of 1/3. I feel like that's too thickly written. To the power of 1/3. Okay, and the 1/3 means that we're taking the cubed root of 216. Okay, and you can pop that into your calculator, right? So it might be important that you figure out how to take a cubed root on your calculator, or you can test it out, okay? And so we find the value, we evaluate it at 1 over 1/6. Great. Let's look at example 3. Okay, there's a negative. Now this is not a negative exponent, so we just take this this rational exponent and rewrite it as a radical as a radical form. Now, I'm a bit concerned because one thing I notice right away is that I'm making the radicand negative. I'm just going to trust Miss Sly and see where this takes me. So the index is 3, and the 4 is the power. Now watch this. There are two ways to write that. You could either put the index inside the radical symbol, or you can put it outside. And you will get the exact same answer. I generally like to make numbers to simplify, and so I will go with this option because what I will do first is take the cube root of -8. And if I punch it into my calculator, I might be surprised to see what's the number. What is the cubed root of -8? Come on, say it out loud. Nice. Yes, -2. Remember, -2 times -2 times -2 equals -8, right? +4, -8. So we can have a negative radicand. In some cases, yes. Okay, now that we have a negative now we have a base. We've got -2 to the power of 4. So 2 times 2 is 4, times 2 is 8, times 2 is 16. And that is the expression evaluated, right? We found the value. Last example. All right, we've got lots of negatives. So we've got some options. Option 1 would be to first clear this negative and write it as a reciprocal, and then to clear that negative. But what if instead we simplified this by multiplying the two exponents using our knowledge of the power rules, right? Ooh. So I get 16, and multiply, it means multiply the numerators. 3 times 1 is 3. 2 times 2 is 4. Negative times negative is positive. So I clear the negatives that way. Now let's rewrite this in radical form to allow us to evaluate it. And again, I'll put the 3 outside so that I can take the 4th root more easily. So what times what times what times what equals 16? Well, take the 4th root on your calculator or take a guess. And that's correct. 2 to the power of 4 gives you 16. So we reduce it to 2 cubed. 2 times 2 is 4, times 2 is 8, right? So it's really good to know your values of 2 to various exponents. All right, so there's the lesson. There is a thinking question. Let's look at this. I won't give you the answer, but I'll prompt you. If the index, right, so the number underneath the radical symbol, oh, sorry. This is the index, I'm tired. If the index is even 2, 4, 6, 8, or the denominator of a rational exponent is even, then the radicand, this is the radicand, must be, and the question is it positive, is it negative, or is it both? For there to be a real solution, i.e. no error. Likewise, if the index is odd, 3, 5, 7, 9, or the denominator of the rational exponent is odd, then the radicand can be positive, negative, or both. Play with that. Figure it out. Use your brain. And we can talk about that on Monday. Okay, a few more things. I wanted to look at a few homework questions, okay, before you get started. So let's look first of all at question 5C. Okay, So when I have a quotient with an exponent, that means both numerator and denominator get the exponent. And so now I'll use the index of 3, the power of 2, on each of the terms. Right, so I have 2 radicands, but the same index and the same power. Okay, now again, I already know this, but you might get used to it. 3 times 3 times 3 is 27. So I've got 3 as the cubed root of 27, so 3 squared over cubed root of 8, 2 times 2 times 2, 2 squared. And that gives me 9 over 4. Next, let's try another one. All right, let's look at question J. So we're looking at this question. So we've got, basically, we've got 2 expressions in radical form. It's difficult to work with them unless I'm in a rational expression. So don't square 5, or don't do 5 squared. Rewrite them in with a rational exponent. So if the index is 3, we're going to have 5, 2 over 3, right? That's the first one. That's this expression. Now, the second expression is just the cubed root of 5. So that means, cubed root of 5 is 1 over 3. And look, we're multiplying the 2 bases. And so that means we're going to add the 2 exponents. 2 over 3 plus 1 over 3. Okay, when we're adding, we just make sure we have a common denominator. 3 over 3, well, that simplifies to 5 to the power of 1, or just 5. Right, so that is the value of J. Moving on, let's look at R. So in this case, I can do some, but I want to rewrite it first in the rational expression form. So watch this. I'm going to start with the 64. And then I see that the first square root is a square root, right? The index is 2. It's not written there. So that means I'm taking the square root of 64. And then if I look, well, now I'm taking the cubed root. So I can rewrite that as 1 over 3. And so I will now multiply these 2 exponents to get 64 to the power of 1/6. And I would like you to figure out how to punch this into your calculator, okay, to get the answer. Now, I'll tell you what the answer is, because the square root of 64 is 8, cubed root is 2. So can you calculate this? And if you can't, let's talk about it Monday, right? But you need to know how to use your calculator. So so in these cases, we are evaluating, we're finding a value. And then if we look at some of these questions, we are now asked to just simplify or write an equivalent expression using exponents. So this is in radical form. So I'm just going to do O. And so what I see is, first of all, this is already written as an exponent, so I won't change that. But I'll add some brackets because I have this this quarter, or this fourth root. So I've got a cubed b to the power of 5, and all of that is under the fourth root symbol, right? So that's 1 over 4. And then I have the 1/2 exponent, right? So that's a square root and then a fourth root. Well, why don't I simplify by multiplying these 2 exponents? All right, so I notice I haven't touched the a and b. And for now, I just have 1 over 8. And 8 becomes my index when I write it in radical form. Oh, I'm not writing in radical form. Sorry. Now I multiply I expand this exponent. So I have a 3 over 8 and b 5 over 8. And then I'll say, should I put it back into the radical expression or in radical form? And I read the question. Write an equivalent expression using exponents. So no, you're not going to rewrite it again using the radical signs because we're just looking to simplify by using exponents. All right, folks, give your homework a shot. I've also shared with Miss Levesque an exit card for 1.1 and 1.2. You might choose to do that once you've done your homework for 1.2, right? Don't do that as your homework. This is an opportunity for you to assess yourself. It's not for marks. It's just an assessment to see if you're on track, if you understand it, right? Or if you want to come into extra help or ask others for help. I hope you have a good weekend. Have fun doing your homework. Make sure to review section 1.1, remembering that our quest is next Thursday. All right. Bye-bye, everyone.